Hello, my name is Chris Fernandez. This is the second video of a series of how to get your Freedom Board i.MX RT1186 to kind of get TSN working. So on the first video, we went over the boards and on the jumpers and setting up the board for us to actually put an image in there for us to test TSN. So in order for us to test TSN, the first thing you got to do is open up the command line on your computer. So from my perspective, I have a Windows 11, so I'm going through the Windows 11 steps here. There are about 9 steps on this. So CMD. And I'm going to run it as administrator, so I have rights and be able to open up files and write to it. As you can see here, I'm on my user's initials here, and the first thing you got to do is actually grab the information from the Git. So it's a command that will initialize a new West workspace in the folder named, and then you can put the name of the folder that you want in there. So for sake of example here, I'm gonna go and grab from the GitHub. I'm gonna get all these files here, and I'm gonna put it into a folder called NXP tutorial. And this is just a version of that I'm actually picking up. So as you can see here, this on the left side here, you can see I don't have NXP tutorial folder anywhere in here. I have an NXP folder, but not an NXP tutorial. So this is what it's going to do. It's going to go into the GitHub and grab all the files and put it into a folder called NXP tutorial. So at this point, I just executing that, and it's going to create a folder here. So let me press F5, and now we can see that NXP tutorial folder was created in there. So now we're going to go into the folder that was created. And we can do a dir in here, see what's going in here, and then we're gonna keep going and to find a folder called scripts inside of this. Let's see these scripts. Now you can see here there is a folder, or sorry, a file called bootstraps.bat. This file here is 1538. We're gonna change this to a specific file that it was given to me by the NXP guys to initialize all the machine, and that's the first thing it does. It kind of, what it does is runs the initial environment setup. This creates your isolated Python virtual environment on your machine here and grab all the necessary modules and initials that's necessary to actually and all the dependencies that you need for you to build the code. So let's go in here, and the script, it's called the magic script here. This script is what we modify. This file I got from one of the guys from NXP. I only changed the 2 things in here that I had to do in order to work, was to add this line here. And I think that was about it. So if you go into that folder, this bootstrap here, let me try to go in there. I'm gonna open, it's under this PC, users, and then it's gonna be under NXP tutorial, and then under scripts, and it's the bootstrap for the Windows. The SH is for Linux environment. So as you can see here, it's a little bit different. It doesn't have all the stuff that I need. So I'm gonna modify this so I can delete this, and I'm gonna copy everything from here into that bootstrap, and I'm gonna save it. Now that it's saved, I should be good to go. So I saved this, close this. I'm gonna go back here now. If I do dir again, you can see that the bootstrap now looks very different. So at this point, I am just gonna run the bootstrap. So and it's gonna take a little bit. So I'll come back and resume the video. But at this point here, all you're doing now is setting up the environment to actually do the build. So it's going to create a Python virtual environment for us in order for us to actually start going. So at this point here, we're just going to run bootstrap. So bootstrap.bat, and that's it. So this is going to take a while. I'm going to pause the video here and I'll come back as soon as this is done. It's going to take a few minutes, more like 10 minutes or so. All right, I'll be right back when this stops. So at this point, Bootstrap just finished initializing your environment, and so now we just have to kind of activate the environment. So we do, and we'll go in there and we change the environment now, so we can see that we activated now the virtual environment. You see the little parentheses here right in front of it. So now it's a matter of for us to set a path. So we're setting a path here. This is let me just copy and paste here really quick. So what this does, this is creates a temporary Windows environment to point to build system exactly where you want your ARM GCC compiler and toolchain is located. So this is just creating a path for it. So at this point now we're almost ready to go, almost to start the build. So we just need to go to the directory called MCUX XCS. So I copied that somewhere on the notepad here so it's easy for me, so I don't make mistakes when I'm doing this video. So it's just a CD to this, and now we are ready to actually build the image. It shouldn't take long, but at this point here, that's where everything now is set. You have all the files, you got your environment ready, and now you're ready to go. So this is the last step of this process, actually creating a build. So it's gonna take a few minutes. It's using the CMake that we have downloaded. It's in the system, and to create the files that you're actually gonna go and put into the board. So just before, as it's finishing here in the board, so as you know, we are connected here on J23 for regular communication to the board, and we're also going to make, for us to burn the image or write the image to the board, we need to go into J63 here. So this is how we communicate to the box. So in order to do that, this is the other. So this provisioning tool, security tool that's downloaded from NXP, that's what we use to burn or to write the image to the board. So let me bring that up while the board is finishing up. So you can see here it's kind of ready to go. I did this before, that's why it's already pointing to the correct place where to the build. So let me pause a little bit here and wait for it to finish the build, and then we can come back and continue. So at this point now we do have an image. It's in the directories, the NXP TSN workspace, the one that we just did. So let me go back there to the tutorial to build to use the image that we did. So it's actually under C users. C Fernandez NXP tutorial, and then it's going to be here and built, and this is the image that we are looking at. So I'm going to do that. Now we can just build. So let's build the image. It's going to take a few seconds, so you're going to see that the image got built correctly with the green arrow here. So now we're actually ready to write to the code, to the board. So I need to turn my board on. It just right now it's off. Give me 1 second. So before I turn the box, before I turn the NXP board on, I'm gonna have to switch the jumpers. So the red dip switch here should now be in order for you to get the serial connection here using the J63. The switches have to be set to 100 instead of 001, which is the default. So we're gonna do 100. So now we're gonna have access to the serial connection, which is the J63 on the screen. So I got the board back in. I switched to 100. And for you to test the connection, you can click on here on this USB here and say test connection, and it should say now it's should be testing for us to see if everything's okay. It's going to take a few seconds and then it should work. And after that, no, so the test is okay. We passed that. So now that we did build, so now we have to write. So we write to the board. And that's pretty much it in terms of getting your board to start. Now we can actually start testing TSN. So for us now, let's go back after it finishes the writing to the code. We're actually going to be able to connect to the board. So I'm going to try to open up mobile term here while we do this. So the image was actually written to the board. So we're going to power off the board again. Change the switches back to 001. And I'm going to open up a console to it. So let me close this. It's going to be in the serial. It's going to be the board is off, so it doesn't see it. Turn it back on. So it's going to be in the serial. It's going to be port number 1 here. This MCU link via port 1. The speed is going to be 15,200, and the terminal settings here, the only thing you got to do is change this to implicit CR, and you click OK, and then you click OK again, and we should now see the board that has pulled up the TSN image. And as you can see here, there's a GPTP is already running on the board. You can see here port 1 and port 2, port 0 and port 1, looking for domain 0 and port 1 is on domain 0 again. Now for us to test this, what we need to do is to go into my mini, right? So we're going to the mini here, and we are going to just click create. See if I have files here that I already saved. Nope. So for samples, we can do TSN, and we can have. Let's use. There's a bunch of in here, but I don't really have 2 domains. I only have 1 domain. So let's use this here, and then we change it to just 1 domain, so we only have domain 0. I don't know how to do domain multiple domains yet, but I'll figure it out. So if I change this to 1, and I'll change this to 1, so there's only master and slave here. I'm going to pick the ports. So port number 1 is connected to my port 0, and my port number 2 It's connected to my port number 1 on the board. So I think this is all I need to do here. I'm just checking here since I pull up this. I haven't seen this before, so I'm just looking at GPTP, and I have to turn off CMLDS since I don't have multiple domains. I'm going to do that the same thing here. And I think that's about it, because I'm going to have domain 0 on the PTP. So PTP, this is the slave side. This should be the master side. And I'm looking at domain 0. So we should be good to go. So let's start this. I'm going to start protocols here. And we should see the TSN coming up on my Mintly just created TSN board. So let's see how it's going over there. The links are up. Now it should be downloading stuff for PTP and start the protocol. So as you can see here, the master is up and the slave should come up soon. So they're both up. So this is the full way of going from just get the board from the box and doing PTP. So the next video, it's going to be showing you how to test the QBV using the same thing, but this is going to be the starting point where you have two PTP connections working and the box is in a switch mode where port number 0, which is the upper port on the board, is connected here, and this is port 1 in a switch mode. So, and for you to verify this is actually a switch, we can look at the statistics here. And under PTP drill down, if you look into the slave side, which is this one here, you can see that the master clock for it is it's the other port, right? So we know that the master clock information is going from port 0 to port 1, and of course you can look into the offset and so on, which is really good. And my path delay should be around over here. You can see 150, 152 here. So if you go into the DUT itself, the board itself, it kind of gives you the same information. So port 1, you can see here the average propagation delay is 154. Over here we see this kind of very similar numbers. Same with 0 right here, 154. And we see 156. So it's a pretty good connection. And so this is all I want to show for now. If you have any questions, let me know. Bye.